Hello and welcome back to another session of Java9s.com. In this session, I'm going to discuss about one of the most important topics of Java, and that is multi-threading concept. Just before getting into the session, I would like to reiterate a point which I used to tell frequently, that you should always relate a complex topic with real world situations or examples which help you to understand the concepts better and make your fundamentals more strong. In this session, I have tried my best to explain multi-threading concept with good examples, and most of the Java beginners feel this concept is more complicated or confusing. So let me explain this session. So let us take some examples about multi-threading or multitasking. Most of us have mobile phones. Everyone now has a mobile phone. Now imagine a situation where we're speaking on a phone and still we'll be able to eat the food, and going further, some smart people can even watch TV, simultaneously talking on the phone, and they can also eat. So as humans, we're good at multitasking. Our brains are capable of shifting the priorities between these tasks, and still we'll be able to perform all of them together with ease. In the same fashion, computers are designed to perform multiple operations in parallel so that different processes execute in the system. Just like we're able to play music, and also we'll be able to work on the document in parallel. So the operating system and processor helps to make the multitasking possible. So multi-threading in Java gives the same ability to execute code by multiple threads, so that different tasks can be done in parallel, or task need not wait for another task. The threads can do their own individual work without waiting for other tasks to be complete. To explain better, computer games are the best examples of multi-threading concept. The ability to make different objects act on a platform is enabled with the concept of multi-threading. Anyone who played Road Rash, you can see that there are different bikes competing with each other with your own bike. All the other objects are driven by the game application. Age of Empires is also a good example of multi-threading. We'll see a good demonstration of multi-threading in Java. So let me explain about threads in Java with a simple example. See, I have a method called download, which downloads the files when you give a URL. Now, when you want to download 4 files, you execute this method for 4 times, one after the other. But what if the files are too large and you want all files to download in parallel? You just want to kickstart the download and all of them should start getting downloaded. So we should be able to execute this method in parallel for 4 times, right? That means 4 different threads have to execute this method simultaneously to download the files in parallel. So for us, thread 1, thread 2, thread 3, thread 4 are the 4 different threads that will execute the code of download method. Now you should understand a point that here you don't need 4 different objects to invoke the download method for 4 threads. Just 4 threads can invoke a single method in an object. So all the 4 threads can execute the method's code in the object. So we'll get into more details about how threads really work. So this is just an outline example of how threads work inside the Java. So I'll explain a lot of other examples as well, which makes it more clear. So remember that when it comes to thread, it is important that you should be able to imagine things how they are getting executed, to be able to debug the applications better. So let me take a real life example to explain how threads can be imagined. Let's consider we have 3 electrical devices: a fan, lamp, and an iron box. Now think that these devices are connected to the ports, which are connected to multiple lines. When you power any line, these devices will start working, and even powering all the lines together will also make them work. So you can imagine the power through different wires to be threads, and all these electrical devices can be objects. That means one single thread can make these devices run, or multiple threads can also execute or make these devices work. So I hope this example will ignite some imagination towards multi-threading concept. Now coming into the concept of process and threads, some people argue that process and threads are not different, but I think they're surely different. You can think the process as an application running in your operating system. It can be a Word document or a PowerPoint or something. Consider this Word application. It is a single process. We call it as a single process. And when you type a word in this Word application, a spell checker in the background will keep working to correct your words. This particular spell check job can be considered as a thread. A separate code which is executed by threads to keep monitoring your words, whether you're typing them on right or wrong, and it will highlight the wrong words or grammatical mistakes or whatever. So when it comes to process, you can say that a single process like Word application can have multiple threads in it. So a process can have multiple threads in it. So a good example is spell checker in the Word. So in the same way, when you run a Java application can have multiple threads in it. and these threads can perform different activities in the application. So coming to the threads concept again, we have to remember few points here. That first, as per the definition, a thread is nothing but a thread of execution which executes the code. So this is a kind of straight answer in the interview, but interviewer will expect more. So it is up to you to give an elaborate explanation for him. Now remember, every thread, every application has threads running in the background. Without thread, there will be no applications that will be run. So when you use Java class, I mean, like when you type Java space some class name to run your Java code, your main method starts getting executed. What does it mean? It really means that the JVM is creating a thread to start executing the code from the main method, and we generally call this particular first thread as a main thread. So without threads, remember, your applications are not going to run. So at least one single thread should be there to make your application run. They can be multiple threads. And remember, it is the operating system which schedules the threads to be processed by the processor. So processor is like, godfather of the whole system, where operating system is like it's one of the minister who schedules the appointment of these threads with the processor to execute their code. So operating system has got a scheduler, and remember, JVM has got a thread scheduler. Each and every JVM from a different company can differ here. So threads there, but there is a thread scheduler. So when your threads are getting executed, it is thread scheduler in the JVM, which again negotiates with the operating system scheduler to request the processor to execute the code again. So it's an two-level process again. So again, in this whole bunch of complicated process, remember, there's no guarantee that a thread will get executed at this particular point of time, or you cannot guarantee that this thread will start running at this moment, or immediately it will be given a chance to run the code or something. You cannot guarantee anything when it comes to thread. So we'll get to see about these states of thread in the next session. So first we'll start learning about creating threads. So now you're completely on board of the thread tutorial. So let's start learning about creating threads and executing them. So threads can be created using the thread class in Java. That means the thread class here is from java.lang package, and when you say thread t is equal to new thread, all you're doing is you're creating an object. So remember, this is just an object. It is not a thread. It is just an object, just like any other object you create in an application. So it is not really the execution engine at this point of time. So when it starts behaving as a thread is when you call its method t.start. So you have to invoke start method on the thread object, then only it will start. But where should it start? So for the main thread, it knows that it should start executing the main method. For a normal thread, where it should start. So there is a method called run method, which is the starting point for any thread. So when you say t.start, the object looks into its own run method and starts executing the code from here. So whatever the application code you want to run, you can put it here and you can start linking it here. So when you say t.start, the run method will be invoked and immediately the thread will start executing it. So remember that the moment when you call start, invoke start, there's no guarantee that immediately run method will be invoked and your thread is in a running state. So it all depends on the scheduling. So you might expect you can expect a delay, or you can expect it to get executed immediately. So remember, when start is invoked, the immediate code that will be executed is the run method. And you should remember that the run method is from the thread class, which is from the java.lang package, but this is already implemented method in thread class. Who has implemented it? It is the Java developers who developed the Java API, but they don't have any idea about our application. That means the run method in the thread class has no link to our application. So remember that run method has no prominence in thread class, so it has to be overridden. So now we're going to create the real code which links our application. So what I'm doing here, I created a class called downloader which extends thread. And what I'm doing for the constructor of this downloader, I'm requesting a URL from which the file can be downloaded, and I'm storing it in this variable. And I have a run method. I'm overriding the run method of this thread. And what I'm doing, I'm creating an object of type called file downloader, which has the download method which can download the file for us. And with this instance, I'm calling the download method. Now whenever you call a run method, a new object of file downloader is getting created. So first, to start 4 different threads to download the files in parallel, what we have to do, we need 4 different objects of downloader thread. Yes. So what I'm doing, I'm creating 4 different objects, downloader dt1, dt2, dt3, dt4, and I'm giving some URL here. So what happens now, they are just objects. Until unless I call start, the run method will not be executed. So here what I'm doing is when I create these new objects in the Java memory, virtual memory, you have 4 thread objects. And when I say d1.start, d2.start, what it does is that it is executing run method, because of which we have an file downloader object for each and every thread. So through which this download method is going to get executed. That means 4 threads have got 4 different objects. So you should remember that whenever you have whatever the code it is, whether it is creating new objects or using the existing object, whatever it is, the threads will execute just like your main thread and start creating objects, and they have their own stack. So we'll discuss about the stack of threads. So remember, when you say start, the 4 different threads will start downloading the file simultaneously. So now with this example you learned how to create threads. Now we have created a downloader and we have extended thread and we override run, through which we have actually connected to our application. From here we are kickstarting our application. So that's how your run method should have linked to your method from where you have to start executing the code. Now there is something you have to remember and note here as a best practice. Here you have seen that I have created a downloader class which extends thread. Now generally, why do we use inheritance? Basically, most of the time we use inheritance to produce a subclass which is more advanced or better equipped, or which has a latest code than its superclass. So but are we really doing something better than a thread class in what is there in Java? Not really, except that we are just overriding something run method. But thread has more advanced methods called sleep, join, yield, wait, notify, all those methods. So we are not touching any other method out there. We're just trying to override run. So for just overriding run, we are actually giving up the chance of inheritance for the downloader. So generally people call this as an bad practice. So unless until you are really writing something exclusive about thread which is better than the thread functionality that is offered by Java, better you reserve that class and don't extend thread class. So where do you write run method then? So Java API gives you an interface called runnable interface, which insists you to override the run method. Now this doesn't make downloader a thread. Remember, this doesn't make downloader a thread. This is just another class. So it has nothing but run is just as normal method. But to start threads, you have to create a normal thread. Now you can see that I have created downloader D, an object which is of runnable type, and here I am creating a normal thread object. What I am doing, I am passing this runnable reference to this thread, which tells that, my dear thread, your run method is in this particular object. So you can refer to start running the code from this run method. So this is the link we are giving. Without this runnable target, this thread has no idea where to start. So the thread has a constructor which accepts the runnable target. So an object which is of type runnable. and then immediately I have to say t.start, so which starts running this run code. So instead of using this code, it is always recommended to use runnable interface and then give the runnable target to thread. So it is also a good practice. So we'll see about what are the various types of constructors that are offered by the thread. Now, generally when you're trying to create threads, there are three different things that threads are going to work with. So first one is it should know where the target run method is present, that is runnable target, which whatever the class that implements runnable should be available for it. So object in which run method exists, and the second one is you can name a thread so that you can easily identify the thread with that name, so that's a string. And finally you can make a thread to be added to a group. That means you can actually group the threads which does a similar kind of activity, or kind of similar act they are involved with. So a thread can be involved with a group, it can have a name. So based on these combinations they have given the constructors. So every possible combination they have offered us. So there's a no argument constructor as we did earlier. Then there's a constructor with runnable target which will only point to the run method. You can give the runnable target and also assign a name while you're creating a thread. Then you can only create a thread with a name. Again, you can create a thread with thread group and runnable target. So all possible combinations are given for us. And you can see there's something called long stack size. It is about the amount of stack size you can restrict to, and it is very particular to certain JVMs. So you can, for now as a beginner, you can ignore this, but when you become an expert, maybe someday you might need this, so you can refer to the documentation. So these are the constructors that are offered, so you can use any of these constructors to create the thread. Now let us start doing some demonstration of creating the threads and implementing them, because we have seen a lot of theory now. So I would like to implement this thread concept with a small story, interesting one. So everyone would have heard about tortoise and hare story, where a tortoise hare challenges tortoise that will you join the race with me, and tortoise smiles and says, okay, let's see. So what happens in this story is that a hare runs more faster when it starts, and tortoise starts slowly, and hare thinks that it is too fast for tortoise, and thinks that okay, let me take a nap until tortoise comes. Anyway, I'm going to win the race. But tortoise doesn't stop, it walks slowly and steadily, and by the end of the day tortoise wins the race, whereas rabbit loses the game. So it's all about the moral, slow and steady wins the race. So I'm going to implement this small story as multi-threading, where one thread will be acting as a rabbit and hare, and other thread will be acting as a tortoise. So let us see this concept. So now you can see that I have a racer which is actually demonstration of the racer. So you can see that I have implemented racer, implements runnable, and I have a race method for which I have created an loop for 100, say it is a 100 meters race or whatever, so it will iterate for 100 times. And what I am doing is, in the race demo, I have created racer, which is a runnable interface. So what I am telling to this thread is that racer is your runnable target. I am passing this object and I have given the name as tortoise, and for the other thread I am giving the name as hare, and I am starting these two threads. Now what happens when I say start? It should go to run method. And where is your run method? Here it is. So what I'm doing in run method here is I'm just invoking the race of the racer object. So race has a for loop which iterates for 100 meters. Now there are two threads which will pass through the run method. Obviously one thread will tortoise thread and the other one is the hare thread. Now each and every thread will iterate through this for loop on their own on a different track. So you can imagine there are two different tracks now, but the same code is getting executed here. So so anyone can go to any distance. Now what I'm doing, for each and every iteration I'm checking if somebody has won the race. If so, I'm just printing the winner, and for the other thread which has not finished, I'm telling just break because it has already lost. So now let us execute this method, this particular code. So you can see that what has happened. So I have created just printing distance covered by tortoise 1 meter. So hare and tortoise have almost started better, and they have covered almost same way. But here you can see that the scheduler has given tortoise a better chance, and it has covered a lot of distance at a shot. And then again this hare has got this one, and let us see who won the race. So winner is tortoise. So for now the winner is tortoise. So I'm not implementing the sleep method because I have told, as per the story, the hare has to sleep, but for now just reserve it until we discuss about the sleep method. Now let us remember that this thread behavior is not going to be the same all the time. So you cannot ensure that assure all the times that tortoise is going to win the race all the time. Sometimes hare can also win the race. So let us see if hare has got a luck this time. Again this is tortoise. So again tortoise. So again tortoise. So the luck is mostly on the tortoise side. So you can download this example from javaNS.com to try it yourself, and please execute this 2 classes, and you can check if rabbit wins at least once, because anyway in the next once we discuss about sleep method, we'll make the rabbit thread to sleep and halt it for some time, and we'll see about that demonstration now. Because we have seen creating threads and how to execute these threads, I want you to do a simple example for yourself. So I want you to create an application which simulates the running race of 100-meter race, where 5 or 10 participants will be participating in that race. So you got to create 10 threads if you are creating 10 runners, and you make them run, and it is better you assign the names for each and every runner and print who has won the race. So you can post your examples, or if you have any doubts you can ask me. Here is my email address. Please give your comments on this video as a feedback. Like this video if you really like this concept, and you can download this PDF of this presentation from javaNS.com. Follow me on Facebook on javaNS page, and you can follow me on Twitter at javaNS. Thanks, have a nice day, and in the next part we'll be discussing about sleep, yield, and different states that threads transits through. So that's all for this session. Have a nice day. Bye.